Hello, and welcome to the next episode of 3D and 30. 3D and 30 is Velo3D's LinkedIn Live and YouTube Live platform where we cover hot topics in the metal AM industry in about 30 minutes. Today, we'll talk about maximizing buy-to-fly economy with sustainable metal powder. It's a bit of a mouthful there. So we already recognize metal additive manufacturing is more material and energy efficient compared to other traditional manufacturing methods. With a better buy-to-fly ratio, metal AM can reduce the waste you produce during manufacturing by 50 to 80%. In contrast, if you look at traditional processes like CNC manufacturing in the aviation industry, they can have a 10 to 30 to 1 ratio, meaning that they buy 30 times more material than what shows up in the final part. That's tremendous. And we're going to be unpacking how to optimize that and how to push that pretty far today. In today's episode, we're bringing in some special guests, and this is going to be pretty awesome. For the first time, live from the factory floor, joining us will be Rob Higby, Chief Executive Officer at Continuum, and Greg Bartley, Chief Commercial Officer at Continuum. And I'll be your host today, Mike Rogerson. So welcome, gentlemen, to the show.
Thank you.
To have you on. So Greg, can you talk a little bit about your role?
Sure, Mike. First of all, thanks for having us. We're joining you here today from Cloverdale, California. My name's Greg. I joined Continuum from ATI, another metals experience company, and really excited about what we can do here, what we're going to talk about today. My role is commercial. Obviously, it's developing a relationship with customers, demonstrating our value proposition, which we're going to talk a lot about today. I really like the way you've set this up, Mike, with the talk around buy-to-fly and the notion of how to get the most value out of materials. That's what drives the economy here, and we're going to learn a lot about it today. So thanks.
Awesome. Rob, can you talk a little bit about your role?
Yes, hi, Rob Higby, the CEO of Continuum Powders, and also just want to thank the entire Velo3D team for having us here today. As CEO, I work very closely with Greg, and probably half of my duties, the other would be with our operations team, which is responsible for the equipment you see behind us at one of our 3 facilities globally, both here in Cloverdale, California, Singapore, and then also Houston, Texas. Our general agreement is if we can build it, Greg can sell it, and our key objective is finding customers that are most intrigued and interested in taking this step forward that we feel the industry and all of its thought leaders are very much on their way to doing.
Awesome. And so let's just dive right into that. In the world of additive powders, how do you differentiate your company versus others?
Yeah, it's a great question. I think, if you look at the powder industry, it's servicing what we refer to as advanced manufacturing. So it's anything that's consuming powder to create something. Traditionally, that's been done by forging or casting. And we see the advent of advanced manufacturing, starting with, for example, laser powder bed and additive, to be a major differentiator. And what that means is that there's a huge supply of powder that is constantly being consumed. The way we differentiate ourselves is fairly simple. The powder is created through what's called feedstock, which is some form of that element in the form of ore that is typically procured from mining companies, around the world, in some countries like China, Russia, Ukraine, etc. What we do instead of using that ore from a mountain is we actually use scrap, which has been somehow turned into waste from either a powder process or any part removal process. That's what we use to then atomize. As a result, that obviously significantly lowers the carbon footprint, provides the same high quality ASTM spec laser powder bed, DED ready powder, but results in a cheaper product for our customers based on the fact that the feedstock's being recycled, not being procured by a third party. Obviously, the benefits, go into then as the final kind of element, a greenhouse gas reduction story, which is a great thing for the environment as well. So all the quality, same if not better price, and an incredible halo effect of kind of doing the right thing for the environment and sort of going in the direction that we see, powder manufacturing going.
That's pretty awesome. And so we might as well dive into this too. Greg, what is that behind you?
Yeah, so behind me today is our 3rd generation gas atomizing unit. This is a vacuum furnace, heats the metal. We use a plasma torch over a water-cooled crucible. Again, I came out of the metals industry where plasma as a heat source, cold hearth melting, they are the gold standard for quality, purification, making sure that you are introducing the most pure and clean product into the atomization stream. Once melted, again, create a fine stream of metal, gas atomized with usually an inert gas, argon, nitrogen, depending on the product, freezes off into spherical metal powders, just like any other gas atomization process on the planet. Again, the 3rd generation unit behind us, so the company has produced now 7 foundries, as Rob mentioned, both in Singapore, here in Cloverdale, California, where we build our own foundries with our very experienced technical team. And our Houston facility is really the North American manufacturing flagship for the company, and looking forward to hosting you there as well, Mike, in the near future.
That'd be awesome to see. And you mentioned taking a feedstock and kind of creating a bit of a closed loop there. Are there other things that you're doing to maximize the sustainability of this process?
Yeah.
Yeah, sure. So there are basically kind of 4 core inputs, if you will, that create both the costs and the greenhouse gas reduction. We talked about feedstock already. That's 100% recycled in our world. So you can see here on this graphic that we're taking feedstock either from our existing customers, could be a fan blade that's fatigued, it could be a ring segment that has timed out, and or we're using their powder, or just third-party scrap that we procure from partners around the world. Those are 3 different forms, all of which can be atomized. We like to say we're sort of feedstock agnostic. That's sort of the first input. The other 3 inputs are gas, which we being based in Harris County, as well as here in Cloverdale and Singapore, have been able to work with the gas industry to make sure we have the greenest gas available. Same thing with power. And then the final piece would be labor. So that sort of formula results in a math equation where we're providing the most carbon reduction solution of any powder supplier on the planet.
Nice. So maybe Greg, back to go ahead.
Add to that a little bit. The notion of using the feedstock that's already had its carbon footprint accounted for in its original application, and being able to apply that effectively without any additional credit to be applied or any charges to be applied. Locating where we can source green energy here in the Sonoma Valley, in Houston, Texas, where there's a very strong grid where we can source power that is also green, and then the sourcing of our gas that's also produced with green. Doing everything we can within our control to make sure that the carbon input or content in the powder we're producing is as low as it possibly can be. And then the last step is really transportation. The cost to get feedstocks to and from where the waste is being generated to the atomizer can be a component in an LCA study that's pretty substantial. Our foundry behind us is pretty small. It actually fits in a Connex container and can be located wherever it needs to be. Today we're operating them under a roof, but very conceptually and very quickly, these will find their way to our most strategic customers where it's embedded in their process. They produce the waste product. We're going to get back to buy to fly here in a minute. They're going to be creating those metal units, being able to feed them directly into this atomizing unit, generating powder, and in many cases, the printing done also at the same physical location. Right. So again, if you try to imagine how do you take any more carbon inputs out of that process, I don't know what's left. There's just not much left. So really excited about that. Again, it's why our whole team is excited about what we're sharing here, and it's going to change. It's going to change how we think about metal and powder.
Yeah, that's pretty amazing. I didn't realize the whole closed loop within a factory setting. Like if you're a large manufacturer using additive or advanced means, you mentioned it could be even broader. Now you've just absolutely closed the loop to do it all in-house. That's pretty powerful.
Yeah, there's sort of 2 customers that we have, Michael, that sort of either fit into that category or the other. One is again where they just have a big subtractive process or waste process. These could be fatigued fan blades, as we said, LLP in an aviation context, or just a lot of machining at a facility. And in a few of our customers, we're literally designing machining our foundries additive, such that we can obviously take all the chips and stuff that's produced from a machining environment, atomize that very quickly, and then have that powder, put into their additive fleet, such that they can produce, again, from the most pure form of that alloy, the same products that they had just, obviously scrapped out. And the other way is we just, procure, feedstock from our global set of suppliers and pretty much any alloy, and then we participate, like there are dozens of companies that do, in the powder production, whether we're selling to additive machine OEMs, service bureaus or fleets, one of our strategic customers that might have 10, 15 EOS machines, 5 SLMs and 10 Renishaws and hopefully many Sapphires.
And
that
30 or
can
40, right?
Yeah, exactly. Which we're all certified on. And so very easy for us to just come in and, be the replacement, which is obviously high or higher quality, same or better price, and obviously a much more green and environmentally friendly option.
Nice. I do want to kind of get into the process a little bit here. So maybe Greg will hit you up with this question. How is your process? How would you describe it? As similar to other processes, different? Like, how would you describe that to a new prospect?
It's very important. We talk about, we're a new company. We have a new technology. We have patents that protect what we're doing. And that's, frankly, those patents have more to do with the size, scalability, and distributability of the technology. When I step back and say, what are we doing? We're taking metal units of a known chemistry, we're melting them into a pool, and we're gas atomizing. So that process isn't new. The notion, again, fully melting metals to a stream and gas atomizing, it's done through Viga, IGA, and other methodologies. So this chart, I think, is kind of nice because it says, how are we the same, and why should you think of the product quality and what you should expect from our powder? It's gas atomized. There's a full homogeneous melt. It's certified to a spec. I mean, if I say that one more time, it's certified to the spec. I mean, I don't know what else you need. It's high sphericity. This is not a water atomized angular powder. This isn't just a spheritization of powder. It is a full melt and a fresh gas atomization. I also like to say it has a new birth date. I mean, if you're looking for heat traceability, once it comes out of this machine behind me, it has a new heat date. We're reducing the carbon footprint, 100% recycled content. We can reclaim powder and solids. Again, our preference is certainly for solids. As you would imagine, a plasma heat source likes to focus on something solid. It's going to be a lot more efficient. As important is how are we different? We're delivering the same powder, but we're doing it with less energy, less carbon footprint. And not everybody who's in the recycling game of powder does it exactly the same. And again, I think that chart just sort of explains how we're the same, how we're different. But again, bottom line, we're going to feed in a known chemistry. I'm going to pick up a kind of just so you get a sense for how it works, right? We secure feedstock either directly from a customer, from a trusted material handler, third-party material handler, and this would just be an example of bar ends that were waste from a product. Back to maybe buy to fly. Somebody bought 1,000 kgs of something, shipped 800 kgs or some number less than that out of their back door, and this ended up in what would have been their, what do we call it, their scrap bin, or there's something for their scrap dealer to come. But we know what it is, and this is what I come back to over and over again. Is we know what it is, and if the chemistry is known, loading it into the feeder behind me, putting it under a plasma torch and atomizing it, there should be no surprise to anyone that it behaves exactly like, in this case, 718 powder. And it's not going to leave our facility without a lab certification. So if for some reason one of these bars got mixed, not good for us to find it in the lab, but we're going to find it in the lab. So again, there should be a high degree of confidence. We certainly have a high degree of confidence putting it in and putting the cost in to make the powder, but it's never going to leave here if for some reason there was something that was not expected. So this would be a traditional load of what would go into our gas atomizer.
Just to add to that, it's one of the things we talk about with customers a lot is their concern that, oh, this is recycled scrap that's going to be used as feedstock to then atomize my powder. Isn't that a concern? And our question back to them tends to be, exactly where this has come from. Yeah. If this is bar stock, if this is an LLP blade or something that's come off of a turbine engine, you could not have a more pure back to birth records example of feedstock that you'd want to use to then be the feedstock that obviously serves as the ASTM spec powder that you're going to be putting into your Sapphire machine. We sort of challenge our customers to ask some of the white labeling options that are out there. Are they providing that same element? And again, to Greg's point a second ago, we're all developing to a very tight ASTM spec where we have a next generation lab where we're able to do that across any and all the aspects of anything that's standard, let alone what a customer might want in terms of humidity, density, flow, whatever it may be. And then we're able to provide that certificate such that it's as good or better than the powders they've been using on any one of their additive machines historically.
And you kind of hit on this idea of traceability. I know in additive, a lot of the parts that we make are very high-end parts, and they go into mission critical applications. And so this concept of traceability throughout the entire manufacturing ecosystem or workflow, now you've included that into your process kind of by default almost.
You know, Mike, the Velo machines find their way into a lot of developmental applications. People are trying to, improve, trial and error, if you will, on technologies and applications. Through that process, the error stuff, you want to know where it ends up, right? I mean, it's your secrets, it's your approach, it's your technical approach. So working with partners and say, hey, we can take that back. We can provide a complete chain of custody that says we've taken it from your facility. We've sized it such that we can feed it, as I held up here, into something that we would put under our plasma torch and fully melt. And again, whether it's an ITAR part or a development part, where you need to know that chain of custody has guaranteed that it's no longer a part. Now it is a melt pool. Pretty well taken care of the identified characteristics, and turned it into something that now you're going to buy anyways. You know the chemistry, you have a spec, we deliver that spec, and again, so it could be a very circular relationship through a development cycle. There's a design change, there's a power interruption, and a part gets failed halfway through. All those become ideal sources of feedstock that again, the money's already in it, the chemistry's known. Why not put it back in the furnace?
Now you brought up kind of a hot word. You brought ITAR, like a significant amount of the parts that we make, we've got to protect. We've got to protect all the way through the whole process, and nobody's allowed to see them, unless you meet the qualifications for that. So you are able to handle scrapped or feedstock parts that don't meet qualification or that age out or for whatever reason. You're able to handle those and maintain the secrecy or the considerations around them?
We will demonstrate this, the process to keep them secure, where they need to be from a compliance standpoint, and then traceability to the fact that they've been eliminated or liquefied into an indistinguishable part, and provide that chain of record back to the party that's responsible to the governing organization.
That sounds amazing.
Yeah.
I do want to kind of come back to another point you mentioned. You mentioned By2Fly, and I know I mentioned it in the intro. So maybe we could back up a little bit. If you're not familiar with that terminology, talk to us about, what does that mean? What does it mean when we say By2Fly ratio, and what are we talking about there?
Again, talking to a pretty advanced audience here, I assume today. I think By2Fly is something that we recognize. A part that goes on an aircraft is very weight sensitive. Parts that end up in lots of applications, but the notion of buying bar stock and doing heavy amounts of machining and creating massive amounts of turnings or chips is commonly understood, and that waste stream, if you will, goes out the back door. Just challenging the organization to think different, the world to think differently about that. If that By2Fly ratio is 20%, that means that 80% of the material you bought to a spec that was important to you, you're saying it's okay to let it go. I'm saying time out. If you paid for that at 80%, we need to be talking, because that 80%, knowing what it is, again, we're form factor agnostic. If it's a machining chip, if it's a bar end, if it's a stamping and you've got flash, we will find a way to put it in our crucible, melt it, and get it back to you with a specification. Again, I hate using the word scrap or waste, but I don't know what you call it. If you're buying it and you're not shipping out your back door, you're calling it scrap. The customer's calling it scrap or waste. I just see it as a metal unit that you've paid for, you have a pedigree for, and we can maintain that pedigree and return it to you in powder. Because let's face it, most of the powders today are still bought under raw alloys that have been used historically. They're widely available. I always say, we know what this is. The reason we don't throw these away is because we know exactly what it is. If I took this to the trash can, Mike, what would you say to me? Greg, you're irresponsible and you don't care about the planet. Because we know that there's a use for this somewhere else. Nobody does that. Why would it be any different with the 80% of material that you're not flying that you brought in your back door? I'm really encouraging people to think differently about scrap. And
imagine if that can that you just held up there were made of titanium, aerospace grade titanium or space grade Inconel. Like the 10, a couple cents at retail. You talk about some of these materials that we deal with in additive. They're not always easy to come by. Some are easier than others. There's obviously a spectrum there. They're much more expensive. And now as a machine shop owner, you're going to throw 80, 90, 95% of that away. Like the whole thing just doesn't make any sense. And when you tie it all together with a process that allows it to become feedstock again, it starts to make more sense.
If there's a supply chain person on the phone who's saying, I know what you're talking about, Greg, I got a mountain of this in the back of my shop, we should be talking, because this is how we get the most value for the economy, for the metal economy that you're already purchasing. And we should, there's a good fit here. And by the way, Mike, we're going to sell more machines doing that too, right? Because it just makes us more profitable, more affordable and profitable for everyone. So.
And what we've tried to do, Mike, is just be a lot more easy to do business with respect to participating in some aspect of this. I think the simple way we've talked about, we call the circular metal economy. That's a company that's producing tons and tons of waste a month. And there are, hundreds of companies out there, many of which we're partnered with in a lot of the industries you'd expect: consumer, industrial gas turbine, a lot of aerospace and defense, a lot of space. That's sort of the circular metal economy, where we literally can have a closed loop component. On the other side of that, there's some companies that may have, call it 2 tons of powder, 2 tons of failed builds, of tensils, whatever it may be. We will gladly take that as well and either provide a credit towards their next purchase and or apply that to the feedstock that we're going to use to fulfill a 10-ton order, for example. And there are some companies, for example, DED companies, that don't produce a whole lot of scrap at all. And we just act as the recycled feedstock option that is providing that same lower price ASTM quality spec powder that they would otherwise go procure from a less green option. So any type of customer can be fulfilled. And what we want to do is say, we don't care if you produce any scrap or more than we've ever seen. We can work with you very quickly based on our procurement and kind of supply chain capabilities.
And let's maybe go one step deeper into that. When you're talking to customers, what do you find is resonating the most with them, and what is important to them with regard to sustainability, buy to fly, closed loop? Like, what are the things that you see are having the greatest?
Yeah, I mean, first and foremost, it's quality. We have to be the best engineering organization on the planet that understands this much better than our customers and has worked very closely with our additive machine OEM partners. So we take certification, good service level relationships, really getting technically astute with our partners before we then go talk to customers. That way we can confidently say that this is as good or better than any powder option, again, all to ASTM spec, that you would have tried to procure on your own. The second then becomes price. And what we have is a lot of flexibility there. I mean, it's no secret the single largest variable cost for producing powder is the feedstock. When we're able to use any form of feedstock that we can procure with our customers or on behalf of our customers versus going with the mining companies, that obviously results in a better option. And then once that's established, because we recognize people have to run businesses here, no one wants to go green just to go green. Well, that's the value proposition that Continuum brings to the table, which we think is nothing short of spectacular. Not only are we as well priced or better based on our ability to use a customer's existing product, our quality is top notch, but we actually have an option with respect to doing the right thing with the environment. When that starts to become part of the discussion, what we see once we've proven this out technically and financially, companies want to move every one of their alloys that they're consuming powder towards this model, because it's just very obviously kind of where this industry is going. And what we want to do is work with the right thought leaders that can do that, such that we're constantly kind of promoting this route to ASTM spec powder that we've seen a lot of success on, and a lot of customer happiness with respect to our install base.
It's not to name drop here, but everybody's seen the Raptor 3 engine recently. It's made a ton of press, and you look at Gen 1, Gen 2, Gen 3, and the thing that strikes me about Gen 3 is it's elegant. And there's this idea in engineering where you engineer something and then you find this sweet spot of elegance. And if I look at the way you're talking about, traditionally you're making these parts, all the scrap goes out the door, you got to pull feedstock out of the mines, versus what this is, there seems to be an elegance to it where you've worked out some of the kinks, and now it's just working as a cycle, and it just seems to fit really well for the industry. So it's props to your.
I think Rob's comment. It's the way the industry is going. I think the more people that we are interacting with, the lights come on, it always start with quality every time. I mean, no one has written a purchase order because they're going to pay for sustainability. It's just not happening. But quality, and if the quality is proven to be the same, and again, it's to spec. We've printed this on dozens of common platforms. The mechanical properties, not surprisingly, match what you would expect or deliver what you would expect. And when you're answering both of those with a yes, and the price is not, you're not paying a premium. It's often favorable because of then the ESG part it's in the bag. I mean, why would you ever do anything any different? Right. And that's the getting over the hump. And that's why I said I'm so tired of talking about qualification of our powder. It's gas atomized spherical powder to a specification that you already know. And look, I'm not naive. Humidity's got to be right. It's got to be packaged properly. It has to arrive on time. All those things, service and delivery, and you get it. Eliminate variation. All those are high on our priority list. But the powder is gas atomized powder, and it performs as it should. And let's get going, because it's game changing.
And you mentioned more alloys. We've mentioned a couple. Can you talk about what alloys you do provide to the market?
Yeah, the machine behind us, it will melt anything. It's a plasma torch. It doesn't care. We've made powder from over 30 different grades of materials. That doesn't mean we do that every day. We have, again, limited number of foundries. We try to focus where the market is. So naturally, we're doing a lot of nickel alloys. There's a lot of material available. There's a lot of demand for it. That's mostly what we did in the last year. We're hard and heavy into titanium right now, particularly grade 5, grade 23, probably right down the road. We've developed means to control oxygen, which is the big mover on securing machining chips with titanium. They're hungry for oxygen, so we need a process to scavenge the oxygen back. We've demonstrated it. It's not quite ready today, but we can deliver grade 5 today. We're working to grade 23, probably months away. But the domestic demand for titanium is, as you mentioned, just things going on globally. It's important. Everybody asks about it. We're going to be big in titanium as we continue to grow our Houston facility. So, we've done reactive alloys, niobium-based alloys. There's demand for copper. For us, it's probably nickel, titanium, probably reactive, maybe a niobium, and then probably some of the copper alloys down the road. Variations of nickel like MAR M247 there's just a massive push for it right now. There's hunger for it. So we've done it. We've demonstrated it. Continuing to field requests for it. Mm-hmm. Again, some of it's what do you have available, and what is the market asking for, and serving the customers as best we can.
Yeah. And I think what's probably, just riding on the heels of what Greg was saying, what's probably the most fun part of our job, Michael, is going and meeting with a company and asking them how we can work with them to sort of be what we sometimes call internally a powder as a service company. And what we mean by that is saying the moment that either that part is removed, that build failed, that powder is removed from the chamber, we want to take care of that scrap for you. And the next time you see us, we're going to be handing you ASTM spec powder. And that's sort of what we do, whether it's logistics of picking it up, whether it's the treatment that we need to do with the metal as we're getting it to the right spec, could be oxidization removal that Greg talked about, for example. That's where this gets really fun. And that's what we've been able to do, is have the logistics to pick everything up, obviously the atomization capability, and then the real science and magic of what we do is how we treat, prep, get a yield that results to that which the customer is looking for. That is the most fun call. Do we fulfill 50 kilogram powder samples? 100%, and we love doing that. But where I think we really stretch our legs is where we have deeper technical relationships, where we kind of are coming up with that circular economy, either literally in a closed loop or procuring scrap on their behalf, then delivering that for customers. That's where we really get to kind of sort of shine our expertise.
Agreed.
So let's say I'm a smaller contract manufacturer. I specialize in additive, but all my parts need post-processing. So I've got some chips laying on the floor over here from the mills and the CNC machines. Logistically, how would I get powder from your team? What does this logistically look like? How do I continue the conversation, so to speak, to build that in?
Yeah, say call me. I mean, Greg Bartley at Continuum.com will get you a response. But again, if you're generating a waste stream, we want to talk. The phrase there, on the floor. I mean, I don't want anybody to think that we're magicians. If it's mixed with with FOD and things that aren't going to burn off or be cleaned off or can be handled, we're not magicians. But if there's care given to the machining turnings, which again, there's people that are expert at taking turnings, cleaning them, keeping them segregated, and providing them, then absolutely, we will find a solution that captures the highest value, again, for the alloy that you've already bought to spec. Give us a call.
Nice. And, we are right around 30 minutes. So I just want to take a minute to get your final thoughts. So maybe, Greg, what are your final thoughts on this? What are sort of some big takeaways that you want to close with?
Again, I really love the way you set it up, Michael, around buy to fly. It's, for me, I rather than scrap, I like the phrase a metal unit. We know what a metal unit is. And I think that if again, as we've done with other parts of our growing up, I would have thrown a beer can away. Now my neighbors look at me like, you idiot, what are you doing? I don't, you don't throw them away anymore. You know better. You know it has another life, another use. You know what? Buy to fly just suggests that we're buying a lot of stuff that we're not getting value out of. Let's change that.
Rob, I'll let you have the closing comments.
Yeah, I would just say that I think the green world, the sustainable world, has sort of had this stigma that going green costs more money. Mm-hmm. And we are the first company that we feel is very consistently doing having more of a green approach at a lower cost. And if you think about it, water maybe would have been the recycled obvious option 30 years ago, maybe food, a low grade hazardous alloy that never actually changes over the course of time. It may change form factor. There may be some chemistry issues sort of on the outside of it, but the core base Inconel 718 or Ti 64 doesn't actually change. And so that would be the obvious thing to bring into what we would call more of a circular metal economy. Whether you produce a lot of scrap, a little bit of scrap, or no scrap at all, we would love to work with you to join us in this revolution as we see the entire industry going in this direction.
Yeah, I would say if for any of the Velo 3D customers out there, we do have a qualified version of the Continuum Inconel 718, OptiPowder 718 right here on our qualified powder list. So if you're interested, you can contact your Velo 3D representative or reach out directly to Rob or Greg. I'm sure they'd love to field your calls. But that's about all the time we have for today. And so I would like to say thank you to our audience. Looks like we had a lot of folks on YouTube Live, a lot of folks on LinkedIn Live. Love to see the multi-channel interaction. And absolutely thank you for the speakers. It was awesome seeing the facility and talking about this amazing product that you've got. So great job.
Thanks for your time.
Thanks for all you do, Michael. Very, very honored to be here with you guys today.
Cheers.
Cheers. Bye.